All right. So what is 4 with an exclamation point? It means 4 with enthusiasm. No, you're right. 4 times 3 times 2 times 1, which is 24. What's it called? It has a name. 4 factorial. Yeah, that exclamation point means factorial. Factorial mean, factors are things multiplied. So it means 4 multiplied on down to 1. Yeah, 4 factorial. Oh, yeah, it says right here, doesn't it? 4 factorial. 4 factorial, 4 times 3 times 1, 24. Your calculator has a button that'll do it somewhere. They're all different. So sequences and series here in chapter 12. All right, so they're saying write down the first 5 terms of the sequence. What are they talking about? So they're giving me this funny looking curly bracket thing, n over n plus 7. N over n plus 7. N over n plus 7. So there it is. So what they want you to do, so we're talking about sequences now. And what is a sequence? It's a little formula, like pretend that's like f of x or something. It's like a little function, but all you plug in is whole numbers. You don't plug in anything but whole numbers. So you're going to plug in n equals 1, then you're going to plug 2, 3, 4, and 5. That's what they mean by find the first 5 terms. They mean plug in 1, plug in 2, plug in 3, plug in 4, and plug in 5, and tell me what you get. So if I plug in 1 here, I get 1 over 1 plus 7. I get 1/8. So that's the first term produced. If I plug in 2, I get 2 over 2 plus 7. 2/9. Just plugging in for n. Making sense? That's all I'm doing. Plug in 3 now. 3 over 3 plus 7. What's that? 3/10. Plug in 4. 4 over 4 plus 7. And what's that? 4/11. And plug in 5. 5 over 5 plus 7. 5/12. So there we go. There is the sequence. There are the 5 numbers the first 5 numbers that formula produces. They're just saying that formula produces which first 5 numbers. So that's what this section is about. Formulas that produce a list of numbers. Good so far? Just plug in 1, 2, 3, 4, 5. Okay, there we go. So the formula is 2 over e to the n. So they want you to plug in 1. When you plug in 1, you get 2 over e to the 1. When you plug in 2, you get 2 over e to the 2. When you plug in 3, you get 2 over e to the 3. When you plug in 4, you get 2 over e to the 4. And when you plug in 5, you get 2 over e to the 5. There they are. Nothing more complex than that. Just plug in 1, 2, 3, 4, 5. Easy so far? All right. Okay, so they're giving me 1, 1/3, 1/9, 1/27, ... And they're wanting me to write down an nth term formula. So you see how we're playing the game backwards now? Now they're giving me the first 4 terms and asking me for the formula that produces them. Last couple problems, they gave me the formula, had me plug in 1, 2, 3, 4, 5, and crank out the terms. Now we're doing backwards, going from terms back to formula. How do we do that? In other words, you need some kind of formula, and you plug in n equals 1, and you get 1. You plug in n equals 2, and you get 1/3. You plug in n equals 3, and you get 1/9. You plug in n equals 4, and you get 1/27. You get the idea? I need some n formula that when I plug in those numbers for n, 1, 2, 3, and 4, I get 1, 1/3, 1/9, 1/27. Any guesses? What's helpful on these is just start guessing and then tinkering with what until you get it right. Just write something down and check it out. When it doesn't work, tinker with it, try it again, go back and forth. What do you think? No thoughts? Nothing? Don't let the 1 throw you off. What's going to produce a 3, a 9, and a 27? What's going on down there?
Those are all multiples of 3.
Yeah, this is 3 to the first. This is 3 to the second. This is 3 to the third. Right? Don't worry about that 1. We'll deal with him later. Just, you with me so far? It looks like a pattern of 3 to the 1, 3 to the 2, 3 to the 3. Right? So 1, 3 to the nth power? What do you mean?
No, like with the 1 on top.
Okay, 1 over. Okay. Oh, come on, eraser. There we go. So 1 over 3 to the n, like that? It's not a bad idea. What do you think about that? Is that right? Let's test it. Let's see if it's really right. Right? We can test it. So if it's 1 over 3 to the n is right, then when you plug in 1, you should get here 1 over 3 to the 1. Is that what we get? When you plug in 2, you should get 1 over 3 to the second. Is that what we get? When you plug in 3, you should get 1 over 3 to the third. Is that what we get? It's close. It's close. Do you see what's wrong? Plug in 4, you get 1 over 3 to the fourth, but you're supposed to get 1 over 3 to the third.
1 minus 9? I mean 1 minus n?
So 1 minus n?
Instead of...
Like right here, 1 minus n like that? See if that's right. So let's plug in 1. Get 1 minus 1, which is 1 over 3 to the 0. Why did I put a 3 in the top? So it's 1 over 3 to the 0. What's anything to 0 power?
1.
So this is 1 over 1. This is 1. Hey, bingo, we got 1. Let's try the next one. Plug in to the next one. You get, here I'm running out of things here. So try the next one, you're going to get 1 over 3 to the 1 minus 2. Right, I'm plugging in 2 there now. Which is 1 over 3 to the minus 1. What's that? What's 3 to the minus 1?
1 over 3. Which
It jumps up. Remember, negative powers jump to the other side. That'd be 3 to the positive 1 or 3. Oh no, it's supposed to be 1/3.
So switch the n and the 1. So
n
it's
minus 1.
1 over 3 n minus 1.
Like that? All right, let's try that. Get rid of all this. Try again. So this would be 1, plug in 1, 1 minus 1, 1 over 3 to the 0, which is 1. Any 0 powers 1. 1 over 3 to the 2 minus 1, plugging in 2 there, which is 1 over 3 to the 1. Ooh, looking good. 1 over 3 to the 3 minus 1, 1 over 3 to the second. Yes, sir. 1 over 3 to the 4 minus 1, 1 over 3 to the third. Excellent. So there it is. There's the formula producing those terms. Good? Does that make sense? It's all like that? All right. Okay. So 9 minus 18, 27 minus 36. Let me give you a second. See if you can come up with it. So go ahead and try it on your own paper. Yeah, let me give you a minute here. Just to get more. You're supposed to be able to plug in n equals 1 and get 9. Plug in n equals 2 and get negative 18. Plug in n equals 3 and get 27. Plug in n equals 4 and get... Oh, don't worry about... By the way, don't worry about the plus minus. Just pretend... Let's just pretend they all say plus. I'll show you the negative thing in a minute. That's cake. Don't worry about that. Just try to get the 9, 18, 27, 36. How about that? And I'll tell you how to do the negative thing in just a minute. But let me... Everybody got it? What's it going to be? N times 9 or 9 times n. Either way, same thing. That's correct, huh? Because you plug in 1, you get 1 times 9, 2 times 9, 3 times 9, 4 times 9. Beautiful. So it's n times 9 or 9 times n. Same thing. Either way you want to say it. Correct. That's working, right? Now, what about the plus, minus, plus, minus? Did you ever seen before, computer science class or any other math class, what makes signs alternate, plus, minus, plus, minus, plus, minus? What does that? is minus 1 to the n or minus 1 to the n plus 1, depending on whether you want to start positive or start negative. That'll make signs switch back and forth. Why? Because it's negative 1 to some power. So negative 1 to the first will just be negative 1. But then the second will be positive. Third will be back to negative, right? That'll make the sign switch positive, negative, positive, negative. And so, but how do you know which one of those? Well, this one starts, where does this one starts positive or negative?
Negative. Or positive. Starts positive.
If you put in 1, you get negative. Right? If you put in 1 here, you start positive. Because 1 plus 1 is 2, negative 1 to the second is positive. Everybody see that? For n equals 1. So, okay, so which one do we want? We want to start positive, so we want this one. So our answer is 9 times n times minus 1 to the n plus 1. That's the formula that will produce these numbers, this pattern of numbers. Is that good? On that? All right, I'm going to move on if you're good. Okay, so now what they're doing recursively means going back in the sequence. So in other words, let me write out what they're saying. They're saying A1, which stands for the first term. They're saying the first term is negative 4. We just start with negative 4, they're saying. So here's the first term, negative 4. I'm able to answer the first question. But they also want the second term. They want the first 5, huh? They want the third term. They want the fourth term. And they want the fifth term. So they want the first 5 terms. The first one is negative 4. What's the second term? Well, this formula tells you how to get the next term each time. What does it say? It says a sub n is n plus a sub n minus 1. Now, what does that mean? The subscripts, numbers that are low down, this is called a subscript, like a superscript. A power is a superscript, it's raised up. And a low down number is called a subscript, like a submarine is low under the water, right? So these are subscripts, aren't they? Well, they tell you the order of the term number. So what this is saying is it's saying the nth term is n, the number n, whatever that is, plus the n minus first term. That's what that's saying. In other words, let me put it in even more common language. So again, it's saying the nth term is n plus the n minus first term. What does that mean, n minus first term? It means one term back. One term back, right? N minus 1 is 1 lower than n, right? So it's saying any term, put in even more common English, is n plus the previous term. Because n minus 1, that's 1 back, isn't it? That's what it's saying. Any term is n plus the previous term. That's what that little formula is saying. So then we go, oh, so any term, what's wrong with my pen? There we go. Any term is n plus the previous term. So if I want to know, say, A2, I want to know that term. What is it equal to? N, well, no, what's n? That's the number you're plugging in there. Remember, this is A sub n. So it's 2 plus the previous term. What's the previous term? Negative 4. So it's negative 2. A sub 2 is negative 2. It's your term number. It's your n. Your n is your term number, 2, plus your previous term. That's what that formula says. Okay, well, how do we do a sub 3 now? Well, you take your term number, right? Whatever's here goes there. Whatever's here goes there. But, right? Nth term goes there. Huh. Right? 3 plus your previous term. Negative 2 is your previous term. So that's 1. So negative 4, negative 2, 1. Good so far? See how that's working? Can you do the next two? So do the next two. Find the fourth term and the fifth term. Fourth term and the fifth term.
That got easy. Forms a pattern.
Yeah, so the fourth term is 4 plus the previous term. 5, did you get 5? And then get the last one. So it's 5 plus the previous term. 5, 10. And there we go. We good with that? All is well? Do you see the pattern in the numbers?
10:30.
What's the pattern in the numbers?
It just simply by the next number.
What do you got to add to -4 to get -2?
2,
Add 2. What do you got to add to get up to 1 now?
3,
Add 3.
4,
Add 4.
5.
It's just adding one more every time, isn't it? See that pattern? There's always patterns always. There we go. So the first term is 5. I'll fill that box in. We're starting off with 5. Okay, so find the next term. See if you can understand now the language of that formula. Speak that language.
Fractions.
So what is this saying? It's saying any term, this right here is saying any term is equal to what does a sub n minus 1 always mean? Previous term. Right? N minus 1 is 1 back over n squared. That's what that little formula is saying, right? Any term is the previous term over n squared. Everybody good with that? That's how a sub n is any term. A sub n minus 1 is 1 back, previous term. All right, so any term is the previous term over n squared. So if you want to know a sub 2, what is it? It's the previous term, right? It's previous term over n squared. Previous term is 5 over n squared. What's n squared? Well, n's your number right here. 2 squared. 5/4. That's a sub 2. We good so far? It's the previous term over your term number squared. All right, and what's a sub 3? It's the previous term, which is 5/4 over your term number squared, 3 squared, which is 5/4 over 9, like that, right? Now, how do you simplify that mess? 5/4 over 9. Yeah, you put 9 over 1, you flip it up. It becomes 1/9, and you times it, right? It's upside down multiply. Remember, dividing is upside down multiply. Grab that 9 over 1, flip it up. And so we get, what's that, 5/36 is the third term. We good there? Can you find the fourth term and the fifth term? So it's the previous. So it's the previous, which would be 5/36 over the term number squared, 4 squared. So it's 5/36 over 16. We good so far? And then you know what you need to do. Take that 16, flip it up. It's 16 over 1, flip it up. 1 over 16 times it. That's 5 over something too big for me. What's 36? What is it? 576. So there's the fourth term. And now, can we find the fifth term? Fifth term is the previous term. So it'd be 5 over 576 over the term number squared. 5 squared, 25. All right? So make that 25. And then put that over 1, flip it up. 1 over 25 times it. So it's 5 over whatever 576 times 25 is. I'm getting 14,400. There it is. Is that good? Questions on that one? I'll move on. All right, try that one. So try that one with letters. Same kind of thing. Instead of numbers, it's letters. So the first term is capital A. They're telling me that straight out. And so what does this say? A minus 1, remember what that means, previous. So this says any term is the previous plus 7D, doesn't it? You getting used to speaking that language? Are you speaking math formula now? A little better? So the second term is the previous term, which is capital A, plus 7D. We good? All right, well then what's A sub 3? Well, what does it say? Any term is the previous term plus 7D. So A sub 3 is the previous, what's the previous? This whole thing here. Plus another 7D. Right, it's previous plus 7D, which ends up being A plus 14D, doesn't it? We good there? And then what is A sub 4? You get it? It's the previous plus another 7D. So really it's just adding 7D every time, isn't it? And then finally, A sub 5 is the previous A plus 21D plus another 7D. A plus 28D. And there we go. Questions on that? Are we good? All right, I'm going to move on. Okay, so sigma notation here. So does anybody know what is that big? That's a Greek S. That's a Greek capital S, sigma. It stands, like I said, it's a big S. It stands for sum, meaning add up. So it's saying add up the formula K plus 3 and plug in, starting at K equals 1 all the way to N. So in other words, what they're saying is they're saying, hey, take the formula K plus 3 and plug in K equals 1. Move it down here. Plug in K equals 1, and then plug in K equals 2. Then plug in K equals 3. Then plug in K equals 4, dot, 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 all the way, and the last one will be K equals N. That's what that's saying. So in other words, start at 1, go to N, plug into that formula, and sum them up. So let's plug in 1. So plug in 1, you get 1 plus 3, you get 4. Every time we're plugging into the formula K plus 3. That's the formula we're plugging into. So plug in 2, what do you get? 2 plus 3, 5. Plug in 3, what do you get? 3 plus 3, 6. Plug in 4, what do you get? 4 plus 3, 7. Plug in N, last one's N, dot, 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 N, you get N plus 3. And then add them up, put plus signs between them. I should actually do this one like this. Plus, dot, 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 plus N plus 3. That's what they're saying. Does that make sense, that language that formula is speaking? So it's saying plug into K plus 3, start at K equals 1, then 2, then 3, then 4, all the way to N. We don't even know what N is. You just keep plugging in to the k plus 3 formula. Plug in 1, plug in 2, plug in 3, plug in 4. Last one's going to plug it in. And then add them up. That's what the big Greek S means, sum. Sum them up. Put plus signs between all those. So there it is. They say, give me the first, second, and last. So the first term would be 4. The second term would be 5. And the ... last term is n plus 3. So they just want to make sure you know what that thing's saying, that you're speaking his language. We didn't really get an answer. We just said, here's what it's saying. Good on that? There we go. So the sum from k equals 0 to n of 1 over 9 to the k. So take that for me. Where do they want you to start, by the way? What's the first thing you're going to plug in? You start whatever number. They don't have to start at 1. They can start at 0. They can start at 7. They don't have to start at 1. That one's starting at 0, and it does go up 1 every time. So it'll be 0, 1, 2, 3, 4, all the way to n. So they just want first, second, third, and last terms. So can you do that? So that just means for this one, we're going to plug in k equals 0. So it'll be 1 over 9 to the 0. What is 1 over 9 to the 0?
1.
Yeah, it's 1, because anything to 0 power is 1, huh? Good so far there. Next one. K equals 1. 1 over 9 to the 1. 1/9. Next one. K equals 2. 1 over 9 to the second. 1/81st. And the last one, then when we jump to the last one now, it is k equals n, right? This is the last. You always start here and end there. K equals n. Plugging in 1 over 9 to the n. So 1 over 9 to the n. Just like that. Good? Easy enough? All right, I'm going to move on unless you have questions. All right, so they're giving me that list. 2/3 plus 3/4 plus 4/5 plus ... plus 11/12. So there's a list. Which of these formulas produces that list? Can you tell? So what I suggest is just start trying them out. This formula says put in 1 first. So if I put in 1 here and here, I get 2 plus 1 over 3 plus 1, which is 3/4. Is that the first term? No. Wrong. It's not A. Everybody with me to there? Everybody see that? I'm just trying out A, saying, well, they say put in 1 first. When I put in 1, I get 3/4, not 2/3. 2/3 supposed to be. Try B. Put in 1. Put in 1. I get 2 plus 1 over 3 plus 1. I get 3/4 again. Well, is that the same thing? Oh, it goes to tens. Yeah. So that's not right either. A and B are wrong. Try C. Put in 1. Put in 1. I get 1 plus 1 over 2 plus 1. Whoops. I get 2/3. Yeah. Right. And that's the first term. What's the last one? It goes all the way to ends at 10. Put in 10. What do you get? 1 plus 10 over 2 plus 10, 11/12. Is that the end one? Yeah. That's it. The answer is C. Why is it not D? D ends when you put in 9. That'd be 10/11. It ends at 10/11. That's not right. The answer is C. Is that good? Keep moving. Okay, so 7 plus 7 squared over 2 plus on and on you go. You know what, guys? This is going to be really easy because they're kind of giving it to us. Let me show you what I mean. So we got sum from k equals 1, and they want me to put something in this box. What's going to go in that box? That, basically. I mean, that's it. There's the formula right there. Just do it with a K instead of an N. Why K? Because they're using K. Right? There's the formula. Now, the only other thing is, where does it end? N. Yeah. Right? The last one's plug in N. Don't have to think hard about that one. They're handing it to you. By giving you that N formula at the end, just make it out of K, because we're using K, and then N is the last one. There you go. That's easy. That's a handout there. Let's try that one. All right. I'll see who can get that first. That's simple if you think what it's saying. Everybody got that one? Any ideas?
Isn't it just 9?
Okay, let's think carefully about what these things say. Okay, so what is this saying to do? Plug in K equals 1, then 2, then 3, etc., all the way to, remember you start here, you end here.
Oh my gosh, it is just that. It's just 9 times 19.
Correct. Right? You start at 1, you go all the way to 19, and you plug in 1. You think, well, there's nowhere to plug in 1. Right, so it's just 9, huh? And well, then you plug in 2, there's nowhere to plug in 2. Right, so it's just 9, huh? Then you plug in 3, but there's nowhere to plug in 3. Right, so it's just 9. And you're supposed to add these up. That's what this is a big Greek S. Stands for sum them up. All the way. And what's the last one? There's nowhere to plug in the 19, right? So it's just 9. So it's 19 nines added up, isn't it? This just means add up 9 from 1 to 19, 19 times. Does that make sense? So it's whatever 9 times 19 is 171? Something like that. There we go. Is that good? Getting the hang of reading these a little bit better, see what they're saying? All right, so the sum from K equals 1 to 5 of 9K plus 5. So what do? I would just work this out by hand. I just plug in 1, plug in 2, plug in 3, plug in 4, plug in 5. So take the formula 9K plus 5 and plug in K is 1. So 9 times 1 plus 5, what's that, 14? And then take the formula 9K plus 5 and plug in 2. Get 9 times 2 plus 5, what's that, 18 of 23? And then plug in 3. 27, 32. And then plug in 4. I think it's going to be 41, isn't it? And then plug in 5. 45, 50. And what are you supposed to do with all those? Add them up. Because it's a big Greek S. Stands for sum. Sum them up. So add those up. I don't know what you get. Some big number. Does that make sense how I'm doing that? Plug in 1, 2, 3, 4, 5 to the formula. Add them up. All right.